Chapter 8. Ratio and Proportion. In our daily life, we have often to compare two quantities either in terms of their magnitude or their measurements. For example, in an examination, Ravi got 76 upon 100 marks and Raman got 50 upon 100 marks. Their performance can be compared as follows. By subtraction, 76 upon 100 minus 50 upon 100 is equal to 26 upon 100. That is, Ravi got 26% more marks than Raman. By average, 76 plus 50 upon 2 is equal to 63%. We can say that Ravi secured 13% more than the average and Raman got 13% less than the average. By division, Ravi's score upon Raman's score, which is equal to 76% upon 50%, which is equal to 76 upon 50, which is equal to 38 upon 25. This means that for every 38 marks that Ravi secured, Raman's score was 25. When we compare two quantities of the same kind by division, we say that we have formed ratio of two quantities. We use the symbol to express a ratio. We say that Ravi's and Raman's score is in the ratio of 38:25, read as 38:25. Ratio. The ratio of two numbers A and B not equal to 0 is A upon B and is denoted as A to B, read as A is to B, where A and B are called the terms of the ratio. The first term A is called antecedent and the second term B is called consequent. The comparison are made only between same kind of quantities, that is, their units of measurement should be same. The order of the terms in a ratio is important. The ratio of 2:3 is different from the ratio of 3:2. Ratio of two quantities is just a number and has no unit at all. Examples. The ratio of ₹6 to ₹18 is equal to 6 upon 18, which is equal to 1 upon 3, which is equal to 1:3. The ratio of 7 hours to 11 hours is equal to 7 hours upon 11 hours is equal to 7 upon 11, which is equal to 7:11. The ratio of 13 kilograms to 22 kilograms is equal to 13 upon 22, which is equal to 13:22. Ratio in the simplest form. Usually the ratio is expressed in its simplest form. A ratio A is to B is said to be in the simplest form if antecedent A and consequent B have no common factor other than 1. Example. Express the following ratios in the simplest form. 12:36. 27:48. Solution. 12:36 is equal to 12 upon 36, which is equal to 1 upon 3, which is equal to 1:3. 27:48 is equal to 27 upon 48, which is equal to 9 upon 16, which is equal to 9:16. Equivalent ratios. A ratio is simply a fraction which does not change when its numerator and denominator are both multiplied by a non-zero number. Hence, the value of ratio remains unchanged if antecedent and consequent are multiplied or divided by the same non-zero number. We get equivalent ratios if the terms of ratios are multiplied or divided by the same number. For example, 5:7 is equal to 5 upon 7, which is equal to 5 into 3 upon 7 into 3, which is equal to 15 upon 21, which is equal to 15:21. So, 5:7 is equivalent to 15:21. 12:18 is equal to 12 upon 18 is equal to 12 divided by 6 upon 18 divided by 6, which is equal to 2 upon 3, which is equal to 2:3. So, 12:18 is equivalent to 2:3. Comparison of ratios. To compare two ratios, we follow the steps given below. Step 1. express each of the ratios in the simplest form of a fraction. Step 2. Find LCM of the denominator of the fractions. Step 3. Convert the denominator of each fraction equal to LCM. Step 4. Compare the numerators of the fractions obtained from above step 3. The fraction having larger numerator will be larger than the other. The following examples illustrate the method of finding equivalent ratios and how to compare the given ratios. Example: the length and breadth of a rectangle are in the ratio 3:2. Complete the following table. Length, breadth. Solution: the given ratio is 3:2. 1. 3:2 is equal to 3 upon 2 into 5 upon 5, which is equal to 15 upon 10, which is equal to 15:10. 2. 3:2 is equal to 3 upon 2 into 9 upon 9, which is equal to 27 upon 18, which is equal to 27:18. 3. 3:2 is equal to 3 upon 2 into 13 upon 13, which is equal to 39 upon 26, which is equal to 39:26. 4. 3:2 is equal to 3 upon 2 into 14 upon 14, which is equal to 42 upon 28, which is equal to 42:28. 5. 3:2 is equal to 3 upon 2 into 15 upon 15, which is equal to 45 upon 30, which is equal to 45:30. 6. 3:2 is equal to 3 upon 2 into 18 upon 18, which is equal to 54 upon 36, which is equal to 54:36. Hence, the completed table is as given below. Length, breadth, 9, 6, 15, 10, 27, 18, 39, 26, 42, 28, 45, 30, 54, 36. Proportion. Consider the example. Priyanka went to the market to purchase apples. One shopkeeper tells her that 5 apples cost for ₹30. Another shopkeeper tells her that cost is ₹48 for 8 apples. From which shopkeeper should Priyanka buy? The ratio of the apples is 5:8. The ratio of the cost is 30:48, which is equal to 5:8. Thus, 5:8 is equal to 30:48. We say that the terms 5, 8, 30, 48 are in proportion. The proportion is a statement that two ratios are equal. In other words, if two ratios are equal, we say that they are in proportion and use symbol equal or to equate the two ratios. In general, 4 numbers A, B, C, D are in proportion if A is to B is equal to C is to D. This can be represented as A is to B in proportion or read as A is to B is as C is to D. A, B, C, D are called the first, second, third and fourth terms. The first and fourth terms of a proportion are called extreme terms or extremes. Second and third terms are called the middle terms or means. We observe that product of extremes is equal to product of means. If A upon B is equal to C upon D, this implies A into D is equal to B into C. Thus, A, B, C, D are in proportion if and only if AD is equal to BC. Continued proportion. In a proportion, if second and third terms are equal, then the proportion is called the continued proportion. For example, 4:8 is as 8:16. We say 4, 8, 16 are in continued proportion. 2:4 is as 4:8. We say 2, 4, 8 are in continued proportion. Mean proportion. If A, B and C are in continued proportion, then B is called the mean proportion of A and C. A is to B is equal to B is to C. This implies A upon B is equal to B upon C. This implies B square is equal to AC. Third proportion. If A, B, C are in continued proportion, then C is called the third proportion. The following examples will make the concept of proportion more clear. Example: are 27, 36, 63, 84 in proportion? Solution. Method 1. If 27, 36, 63, 84 are in proportion, then product of extremes is equal to product of means. This implies 27 into 84 is equal to 63 into 36. 2268 is equal to 2268. Hence, 27 is to 36, as is 63 is to 84. Method 2. 27 is to 36 is equal to 27 upon 36, which is equal to 3 upon 4. 63 is to 84 is equal to 63 upon 84, which is equal to 3 upon 4. Hence, 27 is to 36 is as 63 is to 84. This implies 27, 36, 63, 84 are in proportion. Unitary method. The method of finding first the value of one unit quantity from the values of given quantities and then the value of the required quantities is called the unitary method. We have already learnt that if price of one article is given, the price of any number of such articles can be found out by multiplying the price of one article by the given number of articles. Example: the cost of 1 pen is ₹12. Find the cost of 8 pens. Solution. The cost of 1 pen is given. The cost of 8 pens will be more, 8 times the cost of 1 pen. Cost of 1 pen is equal to ₹12. Therefore, cost of 8 pens is equal to ₹12 into 8, which is equal to ₹96. For more, we multiply. Hence, 8 pens will cost ₹96.